Good afternoon, everyone. It's great to be with you guys. It's great to be back in the Midwest and share a little bit about AI moonshots and grand challenges. There are lots of them. And I'm looking forward to sharing a little bit of my background, and I hope it gives you some perspective in how I view the world. That only matters in the sense that we're here to talk about grand challenges in AI moonshots. And I think before I dive into the science or the greatest challenges we face, I think it's worth talking about where I come from so you understand how I see the world. So in essence, my story starts on a cattle farm. Ethan, who's on the left, is one of my best friends I grew up with, and Tyler, another best friend. We're the three co-founders who started this. And I grew up in northern Michigan, and I grew up on a ranch. It was a really formative experience. It's where I learned that necessity was a critical factor in innovation, and that scarcity drove true improvement. This lesson ended up shaping what I believe was the most formative view in my life that led to me approaching technology differently and AI differently. My fascination with machines started at an early age. I stumbled upon a yard sale MacBook, which I don't recommend doing, for $40. And it was an iBook. And it was old then. It was not good. I bought it for $40 from a school teacher in my neighborhood. And at first, the capabilities seemed really limited. It was kind of disappointing. I got home and I unzipped it and took out this beautiful white iBook, and I couldn't do anything with it. But I learned to create simple programs and tools, which meant I could start playing games. I could download Oregon Trail. I could do things. And I was like, this is really interesting. Started playing with lines of code and scripting. And this laid a really formative foundation for me in understanding the spirit of creation and building and how critical it is to make things. So let's just fast forward now. I'm in college. Unfortunately, I don't have a college degree. I dropped out. But when I was there, I launched a web service company when I was a freshman. This web service company was launched out of my dorm room with my roommate, Ethan, who I grew up with. And the moment someone was willing to pay for something we built, I was like, man, this is surreal. Somebody's paying us for like this thing we have hosted underneath our bunk beds. And as we worked, we kind of got in a disagreement where I had this epiphany where the amount of energy and dedication and passion required to build something small is pretty comparable to the amount of energy and time and innovation required to build something big. So I was like, why are we doing this? Why not do something that could truly change technology or the world? Why would we build something that's small? This is taking us to the moonshot moments. I'm just gearing you all up. So this first $40 computer, that was my first experience. It was a moonshot moment for me. $40 for a 10-year-old was a lot. And it led to WebAI, the company I created. So the heart of what we're going to discuss today is moonshots and grand challenges around AI. So I build this web service company. We have this falling out. I don't want to be in web service. So I go to school. I get to go to Stanford. I study under Andrew Ng, an AI professor who's known famously for the Google Brain. And it's the first time in my life I was excelling in a field. And I was like, man, I feel like I actually can contribute to this. And AI became my passion. But just like any great story, I came into a dilemma. Every school, not to blame just Stanford, was teaching big data, big compute. That was it. So I'm in these courses, and we're walking through server farms like this, and that's what AI needs to work. And this is 2016, 2017, so it's still really early, right? And I'm a scarcity kid. I grew up on a farm. I was the first gen to go to college. Like, what about my iPhone? What about my laptop? What if I want to build something with my computer? How do I do that? Well, you can't. That's ridiculous. You can't. So this led to me dropping out of school. which led to my moonshot. But we're going to talk about that a little later. But I wanted to frame up the industry and what we're doing today so we can really talk about these grand challenges. So what are AI moonshots and grand challenges? Let's frame up definitions and give some historical context. So I think a moonshot, how I look at it, is it has to be high impact. It has to be something that we believe matters outside of our internal project's existence. So are you building something that matters for society that you think, 10, 15 years from now, what I did mattered? Or did it? I think that that's a critical component. Is it ambitious enough? A moonshot moment for AI is not making ChatGPT faster. It's not making an AI model print a picture when they're already generating images. An AI moonshot is this moment of, instead of flying a plane to Hawaii, I'm going to teleport. You have to think of something that's absurd. That's a moonshot. It's got to be something that no one in your group or peers will agree with. And one of my mentors gave me this great quote that I steal from him because he was one of the early backers of Airbnb, and he invested in us when we were going into our seed round. And he said, if your idea is good enough, no one's going to copy it, because that's a moonshot idea. If it's good, no one's going to do it. Nobody wants to do that. That's a ridiculous thing. So let's frame around these ambitious, inspiring things, because if we do something ambitious, it's inspiring, it causes collaboration, more people want to get involved, and then it has long-termism. Long-termism is this idea of being attached to an innovation for the foreseeable future. We didn't start WebAI because we were looking for an easy exit. You don't do an AI moonshot because you're looking to walk away in a year. You do it because you think it's where you're going to spend the majority of your time and maybe even the rest of your life to solve this problem. So it would be totally inappropriate to talk about moonshots without referencing where they come from. In 1961, President Kennedy decided that we were going to go to the moon. And I think my team sometimes thinks I set audacious goals that are ridiculous, but oftentimes they dwarf in comparison of these other great moonshot moments in society and in companies. Kennedy said we had to do it by the end of the decade. That's an extremely heightened timeline. So this innovation required so much collateral to see it through. So 1961, JFK says we're going to the moon, and it's an ambitious goal for space. But what he highlighted in that speech is something we're going to talk about today, is it catalyzed unprecedented technological innovation around the project. You get rockets, you get tinfoil, you get Corningware, you get all of these things we use today, even things like duct tape came from this program. And it's because when you're making a target and you're setting your target on something that's so audacious, there's typically not even the tools or hardware to get there, which is awesome, right? So that means you have to make everything. Sometimes you get to leverage things that exist, but oftentimes you don't. Now let's get into AI. No more history back talk, but we'll talk a little bit about early AI. So if you don't know Alan Turing, Turing test, 1950, this is where AI was born. 1950, Turing says, we're going to create a test where I have a human behind a divider and another human, and I'm going to set a computer on the other side of the divider. And we're going to call in with programming, and we're going to determine if we can identify when the human's responding versus the computer. And it's totally a blind test. Obviously, they failed. They could tell what the computer was. It was 1950. But this is where AI was really born. Dartmouth College, 1956, says, we love this, Turing. We're gonna take this and we're gonna create the world's largest problem solver. It's gonna be universal. Sounds a little bit like what we're trying to build today. This universal problem solver. Dartmouth College, 1956, they have this conference similar to this where everybody's really excited and they're gonna make a universal problem solver. That's a moonshot. That's what it was. It didn't work. In 1957, just a year after, on the heels of this, they built the problem solver, and it wasn't universal. So they took those learnings, and then let's jump to 1997, IBM Deep Blue. Some of you might remember this. Deep Blue was taking the learnings from Dartmouth Conference and saying, in 1957, and saying, universal problem solving will not happen. So let's do a moonshot. Let's beat the best chess player in the world with this system. That then led to the DARPA Grand Challenge in 2000s, where self-driving was born, and autonomous vehicles learned to navigate complex terrain in that challenge. Then you had ImageNet, which led to the largest image data set in the world, and all of these things started compounding. And probably the most notable moment that people remember is AlphaGo DeepMind, and that was in 2016 when DeepMind's model beat the world's best Go player. And that was like a lightning in a bottle moment that people thought was significant. But those are the history of grand challenges, but let's talk a little bit about the current grand challenges we face. I think there's really two, and two that I think of, and that's what I'm going to focus on today. There's frankly too many to talk about. But the first one involves all of you, and it's one that we should be talking about more regularly. Where do humans fit in a world where AI becomes consistently more objectively capable? If AI is getting more capable, and we see AI systems that can do more than write a poem about a frog, or generate code for an HTML website, what happens when AI becomes so capable, if that happens? How do we handle that? How are we making sure we're building these systems around that? To me, this is the moonshot of moonshots. This is, if there's something to focus on, it should be our role in the future of technology. And if we're not thinking about that, we're devaluing our place in this story. Where do we fit in? Think about the moon story with Kennedy. It was about civilization. It was about humanity. Where do we fit in this audacious goal for humanity? I think that in this story, we need to figure out how AI systems truly work. We need to understand the explainability behind it. We need to understand how humans are going to interact with AI and pour the research and ethical force into that. We need to understand what the redefined and reevaluated human roles look like. And I'm telling you, I work with enterprises that are publicly traded, private. This is a conversation that everyone's having, is where do humans fit in this story? Where do we fit in? Where do our team members fit in? The key isn't to create AI systems that replace humans with this grand challenge, but it's developing systems that we are sure are going to augment and improve humans. This requires us to talk about a lot of ethical issues, which gets complex. This is why I disagree with private models. I think it's a massive risk for human alignment. I don't want one person telling me what their ground truth is and enforcing that across my organization. That's why WebAI needed to exist. I think the same applies with finance and free speech and religion and all these things. This should not be regulated by one private company. And we need to address AI literacy in this to really protect humans. I think making sure we have a society where people understand and are willing to have conversations about the most complex things is a society that's willing to be empowered to innovate and solve problems. So probably the even more controversial is it even possible to reach superintelligence? I have opinions on this. If you want to talk about it later, we can. This is, to me, the second most important grand challenge we face in AI, is can we even solve the problem? I don't know if any of you work in AI, but to illustrate, I'm going to offer you an analogy, and maybe it makes sense, maybe it doesn't. But imagine we're city planners, and we're working on Indianapolis, and 90% of cars driving on the road are going to increase by an order of magnitude in 2 years. And then you all tell me, we have a solution, David. It's going to be great. We're going to add lanes. I'm like, none of us would think that that would actually solve the problem. Yet it's super akin to what we face with AI, and where people are saying we're going to add more data and more compute to make it more capable. It's not looking at the holistic problem. It's not actually a paradigm shift. They're saying, let's add lanes to the road. No one's asking, like, is there enough housing? Like, do we have enough cars? Like, there's all these things that should be talked about similar to AI. It's, for example, if every industry is going to adopt AI in the current method, we don't have enough power in the United States to do that. I don't hear people talking about it. We don't have the grid to support that. So that tells me something's wrong. We're not addressing the problem head on. So beyond those two central challenges that I think are important, there's these hurdles along the way that are kind of intermixed with both of them, and it can be hard to articulate. But at WebAI, we're really focused on this human interpretability. And what that means is we've spent a lot of money and resources on making sure people that build tools with WebAI understand what the AI is doing. We were the first company in the world to attach citations to our training data. And what that means is when we output it with a large language model, that citation is embedded in the base 64. And in a technical term, it means the model is regurgitating and citing where the information is coming from. I had an investor, I'm not going to name the fund, but chew me out for this. And they said, if you're telling them where it came from, you need to tell them if it's true or false or not. And that's where we had a massive disagreement. Our opinion is that AI should serve as a tool to provide information and let humans that are using it make the decision on if it's true or not. That's how people learn. It's a critical force of technology. Aside from that, we have issues of, do these training models, these trained models have the capability of handling adversarial attacks? We have no exposure on this, and everyone's adopting AI and integrating it, but we don't really know what happens when a foreign power attacks. What happens if hackers or adversarials get into your system and they want your AI system to crash? We don't really know how to handle that. And these are all intertwined with explainability and function, and all of this is, revolving around energy being a massive consideration as well, right? We don't have enough energy, and if AI is really innovative, we're going to need to find ways to proportionally scale this with our energy. At WebAI, we've tackled these challenges in all sorts of different ways, and we've solved some of them for customers and enterprises. It's not just a technical problem. It's not just like write a new model, write a new methodology. These are problems that require careful consideration and societal involvement. So what's my moonshot? I've talked to you a little bit about ones that I think, but I'm going to give you even a better example. I don't want to tell you what yours should be or what your company should be. You need to figure that out on your own. At WebAI, I believe we're creating the rails for human interaction by enabling more sophisticated AI systems to live on user hardware. So that sounds really simple. And it sounds like a natural conclusion that I think most reasonable people would say, that sounds great. AI on my device that I own, but why isn't the industry doing this? That's not what they're building. These are smart people. They're smarter than me. They're smart entrepreneurs, trillion-dollar companies attacking AI. Why aren't they doing this? And let's just be really honest with ourselves. Well, and to start, the only AI systems in modern society, like in the last 5 years, that have worked with mass adoption have costed hundreds of millions of dollars, and they've trained on petabytes of data. So there's one reason not to change it. And what I mean by that is the infrastructure they built is the largest moat they have in eliminating people to replicate it. So why would you, if your whole business was built on spending hundreds of millions of dollars, why would you innovate on that? So you see this when you look at companies like OpenAI, who launched ChatGPT. They quickly became a leader that no one could touch. The media said this. No one could touch them. But in a few weeks, it was actually 5 weeks, there were comparable models to GPT and some that actually out-benchmarked in the open source community. How could that even happen? We're at an innovation conference. You guys should know about innovation. How does that happen? I thought startups are disruptive. You know, we change the industry. We totally set new paradigms. We turn industries on its ear. How does Meta get in a race to zero with this startup? And I think the answer is fairly simple. I think OpenAI improved a product on incumbent science. And what I mean by that is the core science that these Gen AI companies are leveraging was created by Google. So naturally, these companies are building in an incumbent zone. That's difficult to have a moonshot in that. So in this, our moonshot is big. The moonshot I mentioned prior that was simple, this WebAI mission to make AI for everyone and enable you to have AI on your device, it's actually a massive moonshot because no one's done it. We're changing the way these systems work at their very fabric. We've redesigned how AI systems download to your device. We've changed the way they compile. We changed the way they execute. We changed the way they trained. We changed the way you use them and leverage them on the interface. It's that rocket goal. Because for us to do it, there was no tool. I couldn't go on like GitHub and download a tool that did the thing. It didn't exist. And that's a moonshot because it's a true paradigm changer. If all of a sudden WebAI achieves this goal and everyone can create models like we want that are state of the art, that changes the incumbent space. What do you do if you're Gemini or Anthropic and all of a sudden anybody can make a model that's as good as yours? That's a true moonshot. It changes. And it matters because we have a long way to go with the adoption. And it matters because not all of us 50 years ago would be using computers. It was only engineers. And AI is that same story. Society advances when we make the complex simple. And we need to enable more people to build great things with AI. In 1984, Apple launched Macintosh and said it was the computer for the rest of us. And I think very similar to that, WebAI is trying to make an AI system that's not just creating another AI company that develops a large language model or designs a system that can compete on a benchmark in the fractional decimal places. And it's not just a black box that's locked away in a data center. It's an AI system that lives in your device, on your hands. And it's what we wanted with the early computer. We wanted this thing that only scientists had access to go to everyone because we knew it was better for innovation. So imagine a world where you're a doctor and you're in a small town, in a remote village, and you have AI on your device that is trained and fitted to the diseases, issues in your region. That's a really compelling future. Maybe you're a kid who grew up in a small town like me and you're using AI to solve a problem in the environment in your town. And why this matters is we still haven't solved this universal problem solver. What we have are systems that regurgitate the internet. We need systems that show true intelligence that enable people to create and solve problems that have never happened. So I'm going to leave you with some thoughts, and if there's time, we'll create some space for QA. This is really cheesy, and I struggled with this because I wanted to delete it. And I thought about it more, and it's probably the most true thing I've said, is that the future of AI really does start with everyone here because you're going to be writing the story. We're making the tools. I'm a scientist that has been building AI for almost 10 years. You guys are going to determine what happens with it. It's very, very little of that is in my control at this point. You are writing that future. And I really hope there's a world where AI is a tool for everyone, not just the tool for the few, and where we see the next big tech breakthrough from anywhere, maybe even like Indianapolis, right? You see a kid build something with AI that changes a market. I think as we strive for these big goals that seem outlandish, maybe AI is on every device in a way that's more powerful than we could imagine, and it's more ubiquitous than an iPhone or a personal device. I think the paradigm changes to not what you can do or what people think you should do with AI, but why aren't you leveraging it? And why aren't you adopting this tool that's so personalized and created by you? I think the biggest mistake we could make is think AI is just about smarter machines. It's about people leveraging technology to become more productive, solve bigger problems, and create a future that we want to live in. So I shared a little bit about my moonshot. I would love to hear what you guys are working on and what problems you're trying to solve. And my question is, if AI is at your fingertips, like companies, WebAI is we're trying to do that. We have a tool that's out today. You're welcome to download it and try it and tell us why it's great and why it's bad. I would love that. But if AI is at your fingertips, what's the thing you're going to build? What's the moonshot that you think AI can help you solve or you can create with AI? The future is now, it's happening, right? So don't make a mistake of thinking AI is just going to like sweep over you. It's happening right now, and it's always better to be the one writing the future than being the person that's like the recipient of that reality. And we all have a role to play in that. We can sit idly by and see where AI lands and try things, or we can generate opinions, because not having an opinion is one. And we need to start pouring in and learning, because this next generation, if we do our job right, we'll have AI integrated into everyday life. And we're going to make these complex conversations that we have at tech conferences, things that our kids talk about at breakfast. Because when you make really, really complex things simple, we empower more people to create powerful solutions. And I am so excited about the future of AI. I think we have a long way to go, and I think we're getting closer, and that's exciting. But I think it's people like you that are going to write probably the best pieces of this story yet, and I'm really looking forward to that. I'm happy. I'll be down here after to talk with you all. If there's any questions, I don't think we can do a mic hand around. There was some feedback I heard earlier. But if there's any questions, I'd like to leave some time. I've got a little bit of time left to answer any questions you all may have. Yeah. So I'll reiterate that. He's saying, what does WebAI do that's different than just like taking an open source model and fine-tuning it on your own device? So WebAI created our own file system. So we own the way the model actually is interpreted on the machine. So if you're familiar with like TensorFlow or PyTorch, for example, those are tools that you run models in. We have something called WebFrame. And what WebFrame does is it changed the way the model is actually executed so you can get bigger models on your device. So I'm happy to show you after too. This isn't plugged in, so I can't run it on the screen. But we're running like Llama 70 and Llama 405 like on consumer grade hardware. It's because of WebFrame files. So we're bringing the biggest, best models into your system, and then we're doing it in an interface in a programming language that we created that makes it easier. And we're managing everything from model creation to deployment. And we manage that all across our network. So no cloud required, but you can use that. So it's we want it to be as easy as like an open source model, but the reality is open source models aren't solving the whole picture. It's a small piece, and companies really struggle to get those models trained and deployed in a way that's meaningful.
So, the title of the talk is Moonshots and Grand Challenges, and I've recently been reading some of Ray Kurzweil's work
Yeah.
and his predictions, and so I'm curious on your thoughts on his predictions, specifically about AGI and the technological singularity.
Yeah.
AGI being, according to him,
Yeah.
invented in 2029 and singularity in 2045.
Yeah.
Do you envision these being not necessarily the first steps, but laying the foundation? And then are there things that are not a part of the equation yet that
Yeah.
need to be in order to go?
Yeah, that's a great question. So I'll summarize this question. It was a great question. He's asking he's been reading a lot on Kurzweil, and he's talking about AI singularity. What are the things? What do I think about Kurzweil? For one, was one question. But additionally, what are the things that are missing in that equation? What are the things to look out for in this chase of AGI. So for me, I think dates are really dangerous. You learn that when you take investment dollars from someone. You don't want to tell them like, I'm going to have X by this date. You want to give ranges. You know, you want to give quarters and say like, we're going to hit that goal this quarter. There's a problem with throwing out these really ambiguous dates because it indicates to me that the definition can morph a little bit. So I think what's better, I mean, he could totally be right too. I think it's very unlikely that we have AGI by 2029. But I think his definition of AGI might be achieved by 2029. I don't know. So my definition is different. When we ship a computer chip out of a factory that is essentially capable of learning and creating systems on its own, I would say we have AGI. I don't think that's what he thinks AGI is. I think he's more so comparing AGI to what we have today. And I think that we are laying the groundwork for that. But I don't think the architectures we're using today are what unlocks AGI, if that makes sense. That's why WebAI is spending so much time on those core technology. We're creating new sciences and new methodologies for models. And I think likely we'll see like a replacement of the transformer, which will lead to AGI. Any other questions? Awesome. Well, thank you all so much. I'm glad to be with you all. I'll be down front if you want to chat. And thanks for coming to my session. Excited to be here in Indianapolis. Thank you all.